Hello and welcome to the review of the recycling machine application. I shall firstly begin by demonstrating what occurs when the program is run. Okay. As you can see, when the program is run, a graphical user interface is constructed with buttons for each item that can be placed in the machine, including a random entry button which emulates putting in a randomized item into the machine. Following this, there is a receipt button to print out what items the machine has dealt with. The receipt will provide a summative statement of everything that has been inserted into the machine and will print into the text area on the GUI. When generating the receipt, a measure of the weight of the items in the machine currently is also generated and displayed as a progress bar. When the machine is over full, it will hide all other buttons and has to be emptied, simulating if the machine had gotten too full. After clicking the empty button, then the buttons and interface will return to normal. The machine also handles the error that occurs when a user tries to print a receipt with nothing on it and displays a warning message. So let's just test that. So, yep, as you can see, an error code of item entry, etc, etc. So if we fill out the machine just quickly, the machine is over full, hides everything. Right. As for the statement of what is in the machine, there you go. Prints absolutely everything that's been entered and gives a statement. Okay, so moving into the code. Starting with the recycling GUI class, which extends JFrame to construct the GUI. It implements action lister to handle the actions generated on the GUI, and printer interface to use the print method. The action perform method, which handles the action event and has if statements representing each button on the GUI, such as the can, crate, bottle, etc. For slot 1, for example, it calls the item receive method with the argument of 1. The item receive method calls the classify item method from deposit item receiver, which will determine what item has been entered based on the slot, and then add the item to the receipt basis. Returning to the recycling GUI. The empty machine button sets the slots to be visible once again and effectively resets the machine. Slot 6 is a demonstration of how the program will handle a random item entry. Random item entry, and uses the random class to generate a random slot. Next is all of the components of the GUI and configuring the font and text areas. Next up is the constructor of the class. Let's see. Which defines and adds all components to the JPanel, as well as sets up all of the action listeners. The next method is the main method of the application, which just instantiates the recycling GUI class and sets the GUI to be visible. The final method of this class is the print method, which overrides the printer interface's print method. In this configuration I have the print method outputting to both the console and the JText area on the GUI to demonstrate the ability to print in multiple places at once. The rest of the code in this method handles the setting of the value of the progress bar and handling if the machine is full after this insertion. Ideally I would have preferred to have handled this outside of the print method. Okay, the next class I will go through is the customer panel class, which serves as the interaction to the outside world. Okay, so in this class, the item receive method calls the classify item method in deposit item receiver, transferring which slot is used. Following this, the calculate percentage method returns the calculate weight percentage from the deposit item receiver, which calculates the percentage of weight used based on the maximum weight and the items inserted. Following this, there is a constructor which takes in the printer that you wish to use and creates the instance of deposit item receiver. Finally, the print receipt method again calls the deposit item receiver print receipt method. Next up is the deposit item receiver class, which serves as the main control system for the application. The first method is create receipt basis method, which instantiates the receipt basis. Following this, the calculate weight percentage method works out the percentage that the machine is full from the items added to the receipt basis and generates a percentage value. The next method is the classify item, which takes the items inserted and generates a new item based on the slot it was assigned here. Along with the correct items, I have a error item which as a else statement. This will create an error item object, which will allow the program to report this as an unidentified object. Finally, it will add the item to the receipt basis. Right, yeah. Let's see. Next, the constructor for deposit item receiver takes in the printer that you are using and assigns what the printer is. The final method is the print receipt method, which will try and compute the sum of the receipt. And if nothing has been entered or an additional error has occurred, we'll output this error in the entry string. Finally, it sets the receipt basis to null so that the next receipt can be generated. Next class is the receipt basis, which its purpose is to house the database of the system and to generate the receipt. So the first method is to add a deposit item to the vector, and then adds 1 to the number to start counting at 1 because the default is 0. Next method is compute weight, which calculates the total weight of all items in the vector and returns the total weight. Next is compute sum, which is the method which will go through the vector and build a receipt string. Here I have a counter for each of the different items, and this is how I can display the total count of particular items in the machine. This is then added to the receipt. The printer interface is an interface. Okay, so yeah, sorry about that. The printer interface is an interface that will handle any printing the application has. This provides additional flexibility in creation of printing methods and further expansion of printing in the future. Okay, so display. Display is an unused class which works with simple tester to enter a predetermined set of items into the machine. Okay, this shows the flexibility of the printer interface. Receipt printer just has a print method which can be called from other classes as it implements the printer interface. Simple tester creates the unused display and adds in predetermined items into the machine and prints the receipt. The next class is the abstract class deposit item. This is the class that all inserted objects are based on. The classes that inherit all have number, value, weight variables, as well as the getName method. Moving on into the different subclasses which all inherit from the deposit item, including bottle class, etc., etc. Bottle class just declares the bottle with a value of 20 and a weight of 10. The can and crate classes work very similar to this. So do all of the objects created like this. However, moving into glass bottle and paper bag and error item, there is an overriding of the getName method. This is to in order to return the name of the object more accurately due to the inability to have class names with spaces, as well as in the case of error items being able to provide a error message in this case.